Hi, welcome to another Biomedical Engineers TV video. As we continue through the Analytical Equipment series videos, I like to cover one more equipment which is modern day, widely used in laboratory, is automated slide staining machine. Let's understand what the staining process in a pathology laboratory is. Microscope cell staining is a technique used to enable better visualization of cells and cell parts under the microscope. By using different stains, a nucleus or a cell wall are easier to view. Most stains can be used on non-living or fixed cells, while only some types of stain can be used on living cells. Cells are primarily stained to enhance visualization of the cell or certain components. Cells are sometimes also stained to highlight metabolic processes or to differentiate between live and dead cells. Microbiology is the least automated of the disciplines in the clinical laboratory. Several procedures in microbiology lend themselves to mechanization, but little has been achieved. A Gram staining apparatus, the Shandon-Elliott slide staining machine, has been developed but has not been widely distributed. We describe here a machine which simply and reliably automates the Gram staining procedure. Let's into the working principle of the automated slide staining machine. First, it is important to note that automated slide staining systems are used for special staining, immunohistochemistry, and in situ hybridization procedures are fundamentally different from instruments designed for routine H&E, hemotoxylin and eosin staining, in that reagents are applied to individual slides in small, controlled volumes rather than fully immersing slides in a large volume of reagent. This is necessary because the chemical reactions involved in non-routine staining protocols are far more sensitive and often require that a series of reagents be applied in a specific order to create bound molecular complexes. Components of auto-staining machines. The first robotic IHC workstation, introduced in the 1980s by Brigatti, achieved the complex steps of reagent application and washing using a capillary action technique between paired glass slides. In the following decades, machines have been developed to manage slide labeling, baking, deparaffinization, antigen retrieval, staining, cover slipping, and digital image analysis. Before we move to different components, let's understand the open and closed system. Automated platforms vary in their flexibility for variables permitted at each of the staining protocol steps. This has resulted in automated systems being designed and described as open or closed, depending on how similar the flexibility is to manual staining and the diverse reagent choices and timing of staining steps. For this reason, open automated systems are the easiest to migrate to from manual protocols with the least need for alterations. Open automated systems are often preferred in research settings, where the main concern may be developing new staining protocols for the growing number of target biomarkers, requiring flexibility in protocol options. Automated systems are described as increasingly closed the more they limit protocols to the use of proprietary antibodies, reagents, and detection systems and restrict the options available in the software to vary the steps of the protocol. The first component in an auto-staining system is the heating system. The term closed is also used to refer to systems that perform onboard heating under the closed lids of the system. Heat can be used for several purposes in the staining process. Slide baking secures a tissue section to the slide and is an option on some current automated staining platforms, but many laboratories choose to do this step in a separate oven, which frees up time for the other steps of staining to increase the throughput on the equipment. The most important function of heating is for heat-induced epitope retrieval. The second component is slide management. Instrument vendors differ greatly regarding how slides are loaded, covered, and batched through the staining process to address overall capacity and speed. Early robotic platforms held paired slides in a vertical orientation to take advantage of gravity to apply and rinse agents from the slide surface with capillary action. This has been replaced in current systems with slides loaded in trays or racks in a horizontal orientation with reagents applied from above and spread around the slide surface by either air or capillary action. The slides are protected from evaporation and drying with various techniques, including covering slides with other slides, cover tiles, or liquid cover slips. In general, there has been a move from the large batches of slides in the past towards smaller batches and even single slide processing. Some vendors consider small trays of 5 to 10 slides to be optimal because multiple stains from the same case can be grouped and are typically released to the pathologist at the same time. The third component is reagent management. The number of reagent containers that can be loaded onto automated staining platforms from different vendors varies greatly. In general, more slots available for reagent containers enables more antibodies and detections to be run without swapping out containers. Some systems offer cooling of reagents, which may be particularly valuable for labile reagents such as alkaline phosphatase. All automated IHC systems require a mechanism to deliver precise amounts of reagents to the slides. Matrix and rotary are terms to describe the motion of the robotic mechanisms that bring the reagents to the microscopic slides in automated IHC systems. The fourth component is waste management. Diaminobenzidine is the most common chromogen used in IHC assays. Unfortunately, diaminobenzidine is hazardous and has a special, more expensive handling requirement as a waste product. If kept separate from non-hazardous waste, the expense of handling or neutralizing the diaminobenzidine is reduced. If, however, the diaminobenzidine is combined with non-hazardous waste, all the waste must be processed as hazardous waste. Several vendors use strategies that limit the initial volumes of reagents required. Examples include employing small, walled-off reaction chambers on the slides or permitting control of the amount of reagent that is dispensed. One vendor employs a unique waste strategy that produces no liquid waste because all waste is collected in an absorbent material within the waste cartridge and disposed of as solid waste. Let's look into types of auto-staining machines. Let's start with capillary gap stainers. Capillary gap stainers force or draw the stain between the specimen slide and another surface. A familiar example of this technology is the Platen-type strainer in use for many years in hematology departments for Wright's staining. Rotating worm gears move slides face down along a platen, a plane surface, which has holes through which stain can be pumped at appropriate intervals. The advancing slides press a switch as they pass each staining station, activating a pump. This principle has been applied more recently to PAP and H&E staining. Because each advancing slide triggers stain application individually, the Platen-type stainer is a linear stainer. The stain is discarded after the slide moves to the next station, so the bulk containers of stain are not contaminated. The second type is a centrifugal stainer. Centrifugal stainers spray stain onto the specimen as the slides rotate past spray nozzles in a spinning chamber. Common applications of this technology are PAP, Gram, acid-fast, and hematology staining. The pre-packaged reagents are in closed containers with pump tubing. This eliminates evaporation and contamination of reagents. The third type of stainer is flat method stainers. Flat method stainers drop staining solutions onto the specimen as the slide lies flat within the stainer. Many immunohistochemistry stainers use this principle. Some employ robotic arms to apply solutions to the slides. Some flat method stainers use a robotic arm programmed with XY coordinates to pick up and apply solutions to slides located in a rectangular grid. Other instruments employ a rotating carousel and swinging arm. The arm picks up reagents and dispenses them as the slides move. This was a simplified video on auto stainer machines. There are a lot of different types of stainer machines depending upon the requirement of the user. We covered some of the more widely used types in this video. If you like the information in this video, please give us a thumbs up and subscribe down below. And I will see you in the next video.